Welcome to Blueprint to Reality. This is your go-to channel for unraveling complex engineering concepts and making them easy to understand. Today, we're focusing on a crucial topic in engineering, incorporating safety features in design. As buildings and structures become more complex, prioritizing safety from the design phase is essential. So, what does it mean to design with safety in mind? Let's find out. Understanding safety in design. First, let's define what safety in design actually means. At its core, safety in design is all about identifying potential hazards early in the planning process and integrating solutions to prevent them. This might involve using specific materials, choosing strategic layouts, or building redundancies that keep a structure resilient under stress. This proactive approach helps engineers reduce risks and extend the lifespan of buildings, machinery, and other structures. Conducting a risk assessment. A key step in safe design is conducting a thorough risk assessment. Here, engineers identify potential vulnerabilities specific to each project. For example, in earthquake-prone areas, buildings need to be able to withstand significant ground movement. The risk assessment helps engineers plan for these unique challenges, using reinforced materials and resilient design principles to enhance safety. Applications of safety in design. Now, let's look at how safety is practically applied. One approach involves choosing materials that are durable and resistant to environmental forces. Fire-resistant materials, for instance, are critical in high-rise buildings, while shock-absorbing materials may be necessary in seismic regions. By selecting the right materials from the start, engineers can ensure that structures stay secure and perform well under various conditions. Redundancy and backup systems. Redundancy is another essential element of safe design. In engineering, redundancy means creating backup systems so that if one component fails, others can take over. Take high-rise buildings, for example. They're designed with multiple escape routes and emergency exits, so occupants can evacuate safely if needed. Similarly, machinery may include backup braking systems to ensure safety even if one fails. These redundancies provide critical extra layers of protection. Prioritizing user safety and ergonomics. Safety-focused design also considers how people will interact with the structure. This is where ergonomics comes in, designing spaces that are easy to use and reduce the risk of accidents. For instance, anti-slip floors, clear signage, and accessible handrails contribute to a safer environment for all users. Considering these details makes structures more user-friendly and reduces risks for everyone. Advancements in safety testing. With advancements in technology, safety testing is more precise than ever. Engineers now use tools like computer modeling, load testing, and stress simulations to predict how a structure will hold up under different conditions. These tests allow engineers to refine their designs and make adjustments before construction begins, ensuring that every structure is as safe as possible right from the start. Conclusion. Incorporating safety features into design isn't just a step, it's a mindset that's crucial for creating reliable, resilient structures. By conducting risk assessments, choosing the right materials, building redundancy, and focusing on user safety, engineers create structures built to last. As engineering continues to evolve, keeping safety at the forefront will be vital for sustainable, future-proof designs. Thanks for joining us on Blueprint to Reality. If you found this discussion insightful, don't forget to like, subscribe, and hit that notification bell for more engineering insights. And drop a comment below. What safety features do you think are essential in design? See you in the next video. Welcome to Blueprint to Reality, your go-to channel for unraveling complex engineering concepts and making them easy to understand. Today, we're looking ahead to the future of building codes and standards. As technology advances and environmental challenges evolve, building codes are adapting to ensure safety, sustainability, and resilience. But what changes can we expect in the future of these standards? Let's find out. The importance of modern building codes. Building codes are essential for ensuring that structures are safe and durable. They set minimum standards for construction practices, materials, and design requirements to protect occupants and the surrounding community. As our built environment grows more complex, codes must keep pace with innovations, risks, and new demands. Updated codes can reduce the impact of natural disasters, improve energy efficiency, and support public health, making them crucial in the rapidly changing world of construction and design. Embracing climate-resilient standards. One of the key areas driving the future of building codes is climate resilience. Extreme weather events, from hurricanes to wildfires, are becoming more frequent, and buildings need to withstand these conditions. Future codes are likely to focus more on storm-resistant structures, fireproof materials, and flood protection measures. For example, regions prone to hurricanes may require buildings to have wind-resistant designs, while areas facing rising sea levels might mandate elevated foundations and water-resistant barriers. Energy efficiency and sustainability. Sustainability is increasingly central to building codes as countries strive to reduce their carbon footprints. Future codes will likely enforce stricter energy efficiency standards, including requirements for better insulation, low-emissivity windows, and efficient HVAC systems. Some codes are already promoting net-zero energy buildings, which generate as much energy as they consume. We're also seeing standards for using renewable energy sources like solar and geothermal becoming integral to building practices, reducing dependency on non-renewable resources. Smart technology integration. The rise of smart technology is shaping the future of construction, and building codes are adapting to incorporate these innovations. In the future, codes might include requirements for integrating smart systems that monitor structural health, energy use, and indoor air quality. Sensors can detect stress in a building structure, allowing engineers to address issues before they become problems. With smart systems, buildings can automatically adjust lighting, heating, and cooling based on occupancy and climate, enhancing both safety and energy efficiency. Adapting for modular and prefabricated construction. As modular and prefabricated construction gains popularity, building codes are being updated to reflect this shift. Prefabricated components are built off-site and assembled on-site, which requires a different approach to code compliance. Future codes will likely establish specific standards for these materials and methods to ensure they meet the same safety and quality benchmarks as traditional construction. This could also streamline the approval process, making it easier for engineers to bring innovative modular designs to market. Promoting health and indoor air quality. The recent focus on health, particularly due to the COVID-19 pandemic, is influencing building standards around air quality and ventilation. Future codes may require advanced filtration systems, increased ventilation, and the use of non-toxic building materials. These changes aim to create healthier indoor environments, reducing the spread of airborne contaminants and promoting occupant well-being. Codes may also incorporate standards for natural lighting and noise control to support mental and physical health. Conclusion. In summary, the future of building codes and standards is focused on resilience, sustainability, and health. By embracing these advancements, we can create buildings that are better equipped for the challenges of tomorrow. Thank you for joining us on Blueprint to Reality. If you found this exploration into the future of building codes insightful, please like, subscribe, and hit that notification bell for more engineering insights. And let us know in the comments, what changes do you think should be prioritized in building standards? See you in the next video. Welcome to Blueprint to Reality, your go-to channel for unraveling complex engineering concepts and making them easy to understand. Today, we're discussing an issue at the heart of many modern cities: urban density. As populations rise and cities expand, engineers face unique challenges in creating spaces that are safe, sustainable, and livable. So, how are engineers meeting the demands of dense urban environments? Let's find out. Understanding urban density. Urban density refers to the number of people living within a given area, usually in cities. As density increases, so do the challenges. More people mean more need for housing, transportation, and infrastructure. But with limited space, engineers have to find creative ways to make cities functional, efficient, and comfortable. This often means designing vertically, utilizing every available space, and creating multi-use buildings that serve various purposes in one structure. Building up, not out. One of the main solutions to urban density is building up rather than out. Skyscrapers and high-rise residential buildings allow cities to accommodate more people within a smaller footprint. But taller buildings require advanced engineering to ensure stability, safety, and accessibility. Engineers use high-strength materials, reinforced structures, and advanced anchoring systems to create skyscrapers that can withstand high winds, earthquakes, and even heavy traffic flow inside the building. Efficient transportation systems. As cities grow denser, transportation becomes a major concern. Engineers are focusing on creating efficient public transportation systems that reduce congestion and lower pollution. Subways, light rails, and elevated trains are designed to transport large numbers of people quickly and safely, freeing up road space and reducing the need for individual vehicles. Additionally, engineers are working to integrate transportation hubs within buildings and neighborhoods to make commuting easier and more accessible. Green spaces and sustainable design. Even in densely populated cities, green spaces are essential for quality of life. Engineers are finding ways to incorporate parks, rooftop gardens, and green walls into urban environments, providing residents with access to nature despite limited space. These green spaces not only enhance well-being, but also improve air quality and help manage stormwater runoff. Sustainable building practices, like using energy-efficient materials and systems, are also a priority to reduce a city's environmental footprint as it grows. Smart infrastructure and technology integration. Another way engineers are tackling urban density is by using smart technology. Smart infrastructure, which includes data-driven traffic management, adaptive lighting, and automated waste systems, helps cities operate more efficiently. By integrating sensors and AI into urban planning, engineers can monitor and adjust to the needs of a growing population in real time. For example, smart traffic lights can adapt to congestion patterns, and sensors in buildings can regulate energy use based on occupancy, helping to save resources. Repurposing existing structures. In cities with historical or existing structures, engineers are often tasked with repurposing old buildings to meet modern demands. Adaptive reuse involves transforming used or outdated buildings into functional spaces, like converting old warehouses into apartments or turning offices into mixed-use facilities. This approach preserves the city's character and minimizes the environmental impact of new construction, making it a valuable solution for dense urban areas. Conclusion. In tackling urban density, engineers are innovating in ways that make cities more livable, sustainable, and resilient. By building vertically, enhancing transportation, integrating green spaces, using smart technology, and repurposing old structures, they're meeting the challenges of urban growth head-on. Thanks for joining us on Blueprint to Reality. If you found this discussion insightful, don't forget to like, subscribe, and hit that notification bell for more engineering knowledge. And tell us in the comments, how do you think engineering will continue to shape the cities of tomorrow? See you in the next video.